Okay, good morning everyone. So today we go to the lesson 11. But before we go to the lesson 11, I'd like to discuss about the test I given to you. So look at this question. Okay, the first one, sketch the graph for the 2 modulus cos x. Okay, and the range given is from 0 to 2 pi radian. So it's 0 to 360 degrees. So how are we going to draw this? We want to sketch y equal to 2 modulus cos x. So in between the value 0 to 2 pi radian. So the first we need to draw the graph for the cos x first. What is the graph for? We need to sketch the graph for cos x. Cos x is in this one, right? In this one. Okay, 0. So up to here is 2 pi radian. In between pi. Here, pi over 2. Here is 3 over 2 pi. Okay, the lettering must be correct. Then this is y. So this is your y equal to cos x. And the amplitude here is 1. Maximum is 1. Minimum is negative 1. No. Because here is 2, right? But we don't do this first. So we do the cos x first. Then once we put the modulus, it means that the graph below the x-axis will move up to above x-axis. So this one we will move up. We will move up. Okay, then another one, 2 mean amplitude is 2. So amplitude here will change to 2. So your graph will be like this. You have to draw equally. I didn't draw equally. You have to draw equally. So here is 2 pi over 2 and 3 over 2 pi. X 0, y. Here is 2 because the modulus is 2. So your graph is y equal to 2 modulus cos x. Okay, this is the first part. Okay, then the second part. Okay, on the same axis, it means that the same graph. You don't draw on another graph. Okay, draw a suitable straight line to solve the equation 2 cos s modulus equal to 1 in the same range. Okay, we want to stack the numbers of solution. You have to understand what does the questions want. The questions want you to stack the number of solutions. So mean that we need to find the if you see the question ask you to stack the number of solutions, mean that you need to find the intersection point. Intersection point. How many intersection point is equal to the how many numbers of solution? Okay, can hear right? So now the second part I give you modulus 2 cos x equal to 1. Okay, now we compare. The first is y equal to 2 modulus cos x. Second one is 2 cos x equal to 1. Okay, the questions now is this one and this one same or not. Okay, 2 modulus cos x same with modulus 2 cos x or not. Okay, if you're not sure, you can sketch this one. Let's say y equal to 2 cos x. Then how are you going to draw this? Okay, 2 cos x. So we need to draw the 2 cos x first. We need to sketch the 2 cos x first. So your 2 cos x is like this. 2, okay, 2 cos x because amplitude 2, right? Then once you modulus it, modulus it means that the negative will become positive. So this is y equal to modulus 2 cos x. So you compare these two the same or not? These two are the same, right? So it means that modulus 2 cos x actually same with 2 modulus cos x. So from here you can say that this one equal to, you don't need to do so many calculation or what. You can straightforward, right? This one equal to 2 cos x equal to 1. So this is y, right? So okay, y equal to 1 is the equations you form. So y equal to 1. How to draw y equal to 1? 1 is here. This is, just draw a straight line, y equal to 1. Not on the part A. Then find the intersection point. 1, 2, 3, 4. So your answer, number of solutions equal to 4. That's it. Okay, then you will get your full marks. Okay, any more question? Okay, don't forget the labyrinth. Okay, so we go to lesson 11 now. For lesson 11, today we are going to learn about 6.4. This is how to prove the trigonometric identities by using the basic identities. Still remember what is the basic identities? The basic identities, the first one is sine square plus cos square equal to 1. The second one, tangent square plus 1 equal to secant square secant square. Another one is 1 plus cotangent equal to cotangent square equal to cosecant square. Okay, that one we can prove by using the magic hexagon. Then another one you need to remember is the relation between the tangent, sine, and cos. Tangent equal to sine over cos. Okay, for proving. Prove means we need to prove from the left hand side to right hand side, or we prove from the right hand side or left hand side. Now, how are we going to prove that? As two methods. The first one, we can prove by simplifying from the left to right. Okay, from the left similar to right, meaning that you can starting from the left hand side expression, you prove until you get the right hand side expressions, or you can do it vice versa. Vice versa means you can do from the right hand side to the left hand side. You see which one have, we always starting with the side we have which has more terms. Okay, more terms to the more simple terms. Compare. Okay, another one is you can simplify the expressions on the left and on the right until both sides are the same. It means that you can prove on left hand side, then it will get, for example, it will get value A. Then you get value A first, then you do another side for right hand side, then it will get another value A. So it means that A and A are the same, right? So from here you can say that left hand side equal to right hand side equal to value A. So this one is proving. Okay, I will show you by few examples. Okay, we look at the first example, example 18 in your textbook. Okay, A, prove the trigonometric identities. You see this, the first one, sine square proof to the cos square. Okay, before we do this, okay, we do revision, your magic hexagon. Okay, tangent square, sin square, cos square, cotangent square, cosecant square, and the secant square. Okay, then what is your three basic identity? The first one and the center is 1. The first one is sine square plus cos square equal to 1. Okay, and then remember the value theta of what inside. Then the second one, tan square plus 1 equal to secant square. And the last one, 1 plus cotangent square equal to cosecant square. First, second, third. Okay, so now we go to the example 18a. So this is right hand side. This is right hand side. So we can start by proving from left hand side. Okay, we start from left hand side. 1 minus 2 sine square a. Okay, we have to prove until it's equal to right hand side. So you see the right hand side got cos square, right? So what we need to do is we change the sine square become cos square. So we use the first identity. Okay, first identity. 1 minus 2 what? Sine square is what? Sine square a is 1 minus cos square a kan. 1 minus cos square a. Okay, from the first identity. So equal to 1 minus, you multiply in, expand out. 1 minus 2, negative become positive, 2 cos square a. So 1 minus 2 is negative 1 plus 2 cos square a. The questions, 2 cos square, we rearrange which sequence we move it. So 2 cos square a. So we prove already. Okay. Then if we want to start from the right hand side also can. We can start from the right hand side also. Okay, so the same questions now. We start from the right hand side to left hand side. See can or not? So just now this one is right hand side, right? So you prove from left hand side to right hand side. So you prove it already. So now see, can we prove from right hand side to left hand side or not? So start from right hand side. 2 cos square a minus 1. Okay, from right hand side. So we want to change to left hand side. Left hand side is sine square, right? So we use the first identity again. So cos square a is what? Cos square a sine square a plus cos square a equal to 1, right? So the cos square a equal to 1 minus sine square a. Okay, first identity. So 2, 1 minus sine square a minus 1. So 2 minus 2 sine square a minus 1. 2 minus 1, 1 minus 2 sine square a. So see, equal to right hand side. Equal to left hand side, right? So you prove already. Okay, that's it. So this is the simple question. So now we look at another question. B. Okay, we have to prove tangent A plus cos A equal to secant A equal to cosec A. So from this, so you think we have to prove from the left hand side easier, or we have to prove from the right hand side easier? this question? Can anyone give me some comments? Okay, from right hand side is here, right? Because as what I told you just now, we starting from the equation expression with more terms. On left hand side we have two terms. Compare with right hand side. Right hand side have only one term because this multiplication, set and cosec. This is multiplication, so we consider this one term. One term proof to two terms will be more complicated. So it's easier that you prove on the side with the more terms. This is the left hand side. So we start from left hand side. Tangent A plus cotangent A. So the first step. So you see this type of question, tangent, cotangent. So once you see tangent and cotangent, the question like this, then your answer letter will be second cosec, right? So it's straightforward, you change tangent equal to what? Tangent equal to sin A over cos A. This one. Okay. So tangent is sin A over cos A. Okay, cotangent. Cotangent is 1 over tangent, right? It's 1 over tangent, so cotangent is the converse for the tangent A. So sin A over cos A for cotangent is cos A over sin A. This one you know, right? If you don't know, you can do this. You can do step by step. 1 over tangent A is sin A over cos A. Okay, so this one move up. So it's cos A over sin A lah. Okay, if you cannot remember, you do step by step. But if you already used it with it, you can straightforward write down. You can straightforward change. So cotangent is the converse for the tangent. So it's cos A over sin A lah. Cos A over sin A. From here. Okay, so from here, sin A, cos A, cos A. Okay, so next what we're going to do, you see, this is multiplications, right? So what we need to do is we have to multiply. Multiplication, Make the denominator the same. Okay, so butterfly multiplication, sin A multiply with sin A, sin square A, plus cos A multiply with cos X, cos square A, over cos A sin A. Okay, cos A sin A. How about now? Can listen? Next. Can listen the voice, right? Can, Okay, so we come to this step. Then what is our next step? Too small the voice. Sorry, I adjust the voice already. So now we come to this step. Then what we need to do is we take out again sine. So what is the value for sine square A plus cos square A? This one. This value is equal to 1. First identity, sine square plus cos square equal to 1. So you get your value. Now it's 1 over cos A sine A, 1 over cos A sine A. So it's 1 over cos A multiplied with 1 over sine A. Okay, 1 over cos A is second A. 1 over sine A is cosec A. Okay, second A, cosec A. So, proof right hand side already. So, proof. Okay, this is the second question. But if you prove from right hand side to left hand side, can we try we prove from right hand side to left hand side. How if we prove from right hand side to left hand side? Okay, so right hand side to left hand side, where is the question? The question is this one. This is the question. So now, can you prove from right hand side to left hand side? Can, but it's complicated a bit. I not recommend. If we prove from right hand side, so it's second A cosec A. Okay, we have to prove to become tangent A plus cotangent A. So this one, we change to cos and sine first. 1 over, this is 1 over cos A, 1 over sine A. Okay, then from here we have to, so this one 1 over sine A cos A, or cos A sine A. Okay, then after this, 1 is what? 1 is what? This one you have to know the identity, some basic identity. Sine square A plus cos square A equal to 1. So we have to put inside sine square A plus cos square A. Sine square A plus cos square A over sine A cos A. Okay, make it complicated. Okay, then we separate out one by one. Sine square A over sine A cos A, and plus cos square A over sine A cos A. And from here, simplify square. This one move. So you will get 1 over cos A. Is it? Oh, sine A cos A plus cos A sine A. So sine A cos A is tangent A. Cos A sine A is cotangent. Okay, cotangent. So negative cotangent A. So from here you prove to the left hand side. So, but the second method is more complicated, so I not recommend. I don't recommend you to prove from right hand side to left hand side, because for this question it's hard for you to visualize. Hard for you to visualize the condition, especially 1. You change 1 to sine square A plus cos square A will be a little bit hard for you to relate. So the easier way is from the more terms to smaller term. Oh, sorry, it's plus. Wrong. Plus. Plus. Okay. Okay, so now we continue our discussion. I will discuss few more questions. I'll let you to look at extra example 5. Prove each of the following trigonometric identities. Okay, left hand side, right hand side. So how you going to prove? Left to right or right to left? So from here you see which one is more complicated, which one more simple. Left hand side is more complicated, right? So for proving, we always start with the complicated one, or the one with more terms. Okay, so we start from left, then we have to prove to right. So we start from left hand side. 1 minus cos x, 1 plus secant x. Okay, so this is the factorizations, right? So we have to expand out. Okay, expand out. The first one, 1 multiplies with 1. You know, right? You know how to do this question, huh? 1, 2, 3, 4, huh? Okay, huh? 1 multiply with 1, 1. Then 1 multiply with second, plus second is, and the second one, cos x multiply with 1, negative, cos x, then negative, positive, negative, cos x, second x. Okay. Then 1 plus second cos. Second we change to cos. Okay, 1 over cos x minus cos x. Okay, this one cos x, second 1 over cos x. So this one can simplify, become 1. So you get 1 over cos x minus cos x. 1 minus 1. No more, huh? 1 minus 1, no more. So you get 1 over cos x minus cos x. So after this, we cannot make it like this one, huh? Because this is what we want. So we have to continue. So continue equal to, this one is over 1, huh? Over 1, huh? We have to make them the same, huh? Make the denominator the same. Huh? How to change 1 become cos x? You have to multiply up and down with cos x, cos x. Okay, so you get 1 over cos x minus cos squared x over cos x. Okay, cos x, cos x, cos squared x. So now up is, denominator is 1 minus cos squared x. Then the bottom numerator is cos x. Okay, so now this is equal to what? This is equal to what? Your identity, first identity, sine square x plus cos square x equal to 1, right? So what is your value for 1 minus cos square x? 1 minus cos square x, 1 minus cos equal to sine square x. Sine square x. So this is equal to sine square x over cos x. Okay. Sine square x is sine x. Okay. Cos x. Okay. So when sine x cos x is tangent x. Okay. So you have tangent x sine x. The question is sine first. So sine x tangent x. So proof. Okay. And this one, if you prove from right hand side to left hand side, will be more difficult. So the easier is left to right. Okay. So another question. Cotangent A plus tangent A in bracket multiply with cos A equal to cosecant A. So of course you see this, we have to prove from left to right. Left hand side. And this is right hand side. We cannot prove from right to left for this question because right hand side is too simple. It's very hard for you to be right. Simplest is we prove from left hand side. Cotangent A plus tangent A multiply with cos A. Okay, cotangent. What is cotangent? Cotangent is 1 over tangent. You see the cotangent for second, and the second you straightforward change into reciprocal for the tangent, cos and sine first. So you see this and this one, you see the tangent, and the cos, you see tangent, cos, then cosec, right? Straightforward, remember this one. Tangent equal to sine over cos. This one, This one you need to know, because it's not in square form, but you need to change into the sine and cos. So, okay, 1 over tangent is the reciprocal, so it's cos A, and sine A, cos A. Do until this step, cos A, then we multiply in, and multiply in cos A, multiply with cos A, cos square A over sine A. Then this one is sine A cos A over cos A. Cos A simplify become 1. Okay, cos square A sine A. Okay, so after this, sine, cos and sine. Okay, this one is cos square A. Cos square A, this one you need to use the identities again. What is the identity? Sine square A plus cos square A equal to 1. So, what is the value for cos square A? Cos square A equal to 1 minus sine square A. Okay, we have to use this. So, continue. Continue to become 1 minus sine square A over sine A. Then plus sine A. Why we want to do so? Because the cosec, the answer, the right hand side is cosec. Okay, so we need to change, make all the things in sine first. Okay, so from here, this one is over 1. So over 1, how to make it become sine A? Sine A, up and down sine A. Okay, so 1 minus sine square A plus sine square A. And bottom denominator, the bottom same already, sine A. So sine square A minus negative 1 plus 1, 0, so it's 1 over sine A. 1 over sine A, change cosec A. So proof already. Okay. So now we look at C. Again, left hand side, right hand side. From this, you know the easier is, yes, again, we have to prove for left hand side. Proof for left hand side is easier. Sine square theta 1 minus cos theta. Okay, sine square theta, sine and cos. The answer is cos. Right hand side is cos. So we have to change sine to cos. Okay, identity. Sine square theta plus cos square theta equal to 1. So sine square theta equal to 1 minus cos square theta. Okay, so we move 1 minus cos square theta over 1 minus cos theta. So after this, how to do? 1 minus cos square theta is what? So from here, we need to do revisions. 1 square minus b square equal to 1 minus b, 1 plus b. This one you know, right? A multiply with A square. A multiply with B is plus AB lah. Then negative B multiply with A, negative AB. Then B with B, negative B square. These two we cut down, so we get A square minus B square. So in this form, if you see the question like this, and also the same thing, 1 minus cos square theta equal to 1 square minus cos square, right? So this one also same with 1 minus cos theta, 1 plus cos theta. Why? Because of the here, I proved to you already. So from here, you know, 1 minus cos square theta will be 1 minus cos theta, 1 plus cos theta. Okay? Get from here. Why? I explain from here. So these two simplify, become 1. So answer 1 plus cos theta. Here, see, we prove already. Then we have another method. Besides this method, I'll show you another method. You can also prove in another way. Okay. Actually, there is a lot of methods. Depends on how you're going to prove it. As long as your proving is correct, then it's okay one. You can set a lot of solution. Left hand side, right hand side. Okay, another way is also we prove from left hand side. Sine squared theta over 1 minus cos theta. So from this one, because I want 1 plus cos theta, right? So I change it 1 plus cos theta over 1 plus cos theta, both sides. So you will get sine squared theta plus sine squared theta cos theta. Okay, so bottoms 1 minus cos theta, 1 plus cos theta, it will become 1 minus cos squared theta, 1 minus cos squared theta. So you get this one we factorize out sine squared theta 1 plus cos theta, okay, 1 minus cos squared theta. Okay, then 1 minus cos squared theta, use the identities sine squared plus cos squared equal to 1. So 1 minus cos squared theta equal to sine squared theta. So here, this one is equal to sine squared theta 1 plus cos theta over sine squared theta. Simplify 1. So it's 1 plus cos theta. So you can also prove by using the identities. Let's say identity also can. Okay, this is various of methods. Okay, now we go to one more question. D. Okay, few more examples on the proof from left hand side. Left hand side, right hand side. So from here, this question. Well, of course, I think left hand side is easier. Left to right easier. Okay, so second s 1 minus sine x. Okay, we have to prove to become cos x over 1 plus sine x. So second is 1 over cos x. Okay, 1 minus sine x. Okay, so after this, what you need to do? 1 minus sine x. You see the relations. Now you have 1 minus sine x. But you want 1 plus sine x. You want 1 plus sine x at the bottom. So what you need to do is you make right hand side 1 over sine x, 1 plus sine x, 1 plus sine x. I want to do so that the bottom will have 1 plus sine x. Okay, so 1 minus sine x multiplied with 1 plus sine x, it will become 1 minus sine square x. Okay, cos x 1 plus sine x. Okay, so 1 minus sine square x plus cos square x equal to 1, the identity. So 1 minus sine square x, 1 minus sine square x equal to cos square x. So it's cos square x over cos x 1 plus sine x. Cos square x, simplify, it will become cos. It will become cos x 1 plus sine x. Cos. So the answer cos x 1 plus sine x. So you prove already. Okay. Can from proof from left to right. Okay, so now by using the same question, I would like to show you another alternative, another way of proving. Okay, how if you found this condition? Let's say now, I did this question. Okay, now for this question, let's say, okay, this is left hand side, this is right hand side. Okay, so from your left hand side, you do this now. Second x, 1 minus sine x. Okay, then one minus cos x, 1 minus sine x. Okay, after this, you will get 1 over cos x minus sine x over cos x, correct? Now we just multiply in. Okay, so you get 1 over cos x minus tangent x. Okay, you start at here, so you don't know how to continue. Let's say you start at here, then you don't know how to continue. So just leave it in this form first. And this is the left hand side. It's not equal to right hand side, right? So never mind. We can do for the right hand side also. Left hand side we stop at this here. Then we'll continue with right hand side now. We start from right hand side. Cos x, 1 plus sine x. See, can do until this step. Is this one right hand side, you can do until this step. 1 over cos minus tangent x. Yeah, also proof already. Okay, because they all become the same at the last. How are we going to do this? Cos x, 1 plus sine x. How are we going to do this? We can do like this. Because the bottom is 1 plus sine x, right? We'll make it cos x, 1 plus sine x. Okay, 1 minus sine x, 1 minus sine x. Why? Because I want to make the bottom to become 1 minus sine squared x. So that I can change it by using the basic identities. Okay, so the upper part is cos x minus cos x sine x now. So the bottom part now is sine squared x plus cos squared x equal to 1. So 1 minus sine squared x equal to cos squared x. This one. So cos x minus cos x sine x equal to over cos square x. Okay, cos square x. Then we'll continue on. This one, cos x over cos square x minus cos x sine x over cos square x. Okay, cos 1 over cos x. Okay, cos, so it becomes sine x over cos x. You see this? 1 over cos x minus tangent x. You see these two are the same or not? So you prove to this step. Left hand side you prove to this step. Then right hand side you also prove to this step, right? So you can write your conclusion. You can write your conclusion. Second x, 1 minus sine x equal to cos x, 1 plus sine x equal to what the same terms you get, equal to 1 over cos x minus tangent x. So from here you prove. Okay, you can prove like this also. If you start example during the exam, you can do left hand side become one particular terms, then right hand side become the same particular terms. Kalau kedua-dua sama, okay, prove already. Okay, we try one more question. Okay, prove that tangent square x minus secant square x plus 2 equal to cosec squared x minus cotangent squared x. Okay, you see this. Now, left hand side, right hand side. Both looked complicated. So, how are we going to do this? No worry, we do step by step. We do the left hand side first. Okay, left hand side. Tangent squared x minus secant squared s plus 2. Okay, tangent. Tangent is what? Tangent is tangent. Just put tangent. Tangent squared x. Secant is 1 over cos squared x plus 2. Okay, cos, tangent and cos, cancel. Sin square, sine square, cos square x minus 1 over cos square s plus 2. 2 don't kacau, huh? So these two we can put together because the numerator, denominator are the same now. The bottom are the same now, huh? So we get sin square s minus 1 over cos square x plus 2. Okay, how to simplify this one? Identity sin square s plus cos square x equal to 1. So sin square x minus 1, huh? This one move here, minus 1 equal to cosec move to right hand side, huh? Negative cos square x, huh? Equal to negative cos square x. So you get negative cos square x over cos square x plus 2. Okay? Simplify negative 1. So negative 1 plus 2, you will get 1. Huh? From left hand side, you get 1. Okay, it's not equal to right hand side, right? So you have to do for the right hand side also. Right hand side, cosec square x minus cotangent square x. Okay, we do, so it becomes 1 over sine square x minus 1 over tangent square x. Okay, so this one become we just say minus sine square x cos square x. See, you see the denominator, the bottom are the same now. 1 minus cos square x over sine square x. 1 minus cos square x, 1 minus cos square x is equal to sine square lah. So equal to sine square x over sine square x. See, they are the same, equal to 1. Equal to 1. So this one 1, 1, left hand side 1, right hand side also 1. So you prove already. Your conclusion is tangent square x minus secant square s plus 2 equal to right hand side cosec square x minus tangent square x equal to 1. Proof. Okay, this is the way for the proving. Okay, so that's all from me today. This is your homework today.